linear inequalities.
Okay.
Yeah. So graph the solution to the system. X squared plus y squared is less than or equal to 9. And then negative x squared plus y is greater than or equal to 0.
Is that it?
And then negative x plus y is less than 2.
All right. Let's take them one at a time. Ooh, hear a strange echo. What's that the equation of, the first one?
A circle?
Of radius?
3.
Okay. So let's make a, I'll use the grid I got here. So that's the equation of the first thing, and less than 9 means inside the circumference of the circle. Second one, if I move the x squared over, with this. Right? Do you hear that echo, Mina?
No.
Okay. I can work through it. But if you're hearing it, it's probably very distinct. Because I may end up talking louder because I have to kind of talk over my own voice. What's y greater than x squared mean? What kind of figure is that? What's y equal to x squared?
What?
What is that figure? What is that graph?
I'm not sure.
It's a parabola? Like that. And the greater than means everything greater on the y-axis than that equation. Okay? So now our solution from just the first two is everything in this area right here. Now let's add the third one in. We've got y is less than x plus 2. What is that the equation? Mina?
You got cut off.
I'm sorry?
You got cut off.
Okay. What is
You
y?
got cut off.
Can you hear me now?
Okay. What is y? Can you hear me now?
Yeah.
You can? Wondering if there's not a better way for me to do this. You have a speakerphone?
Yeah.
At your computer so that I could call you on your speakerphone and we could do the audio that way?
Sure.
Let me, because I think you're having a hard time hearing me. Let me think for a minute here how I can, I don't know. Do you feel like the audio is okay?
You kind of break off sometimes.
Let me try calling. Should I call the same number?
Yeah.
Let me call it on my Google phone and see if I can't get a little better audio. Hold on. Let's see. 720-737-8936. See if this improves things.
That's much better for me. Okay.
Yeah, but also the video is lagging.
Okay. That's something to think about. So what is the third inequality an equation of, or an inequality of?
So linear
First
equation.
one was a circle, the second one was a parabola, what's the third one?
Linear equation.
Yeah. So if I graph it, got a slope of 1, a y-intercept of 2, goes through that point, the slope of 1, something like that. And since y has to be less, look to the y-axis, we've got to be below that line. Let me erase some of this other that I've drawn in there. So, to be below that line is going to be, I'll draw my circle back in there. So, for all of this, the area has to be below the line, inside the circle, and above the parabola. Like that. There is our shaded region where everything is true. We're inside the circle, we're above the parabola, and we're below the line. Okay?
Mm-hmm.
Got another one?
Graph the inequality x squared plus y squared is greater than 36.
Is there more?
No,
Or just that one?
just that.
Just that?
Mm-hmm.
Got it? What's that the equation of?
Circle,
What's radius?
6.
And it's a dotted line, not a solid. It's a dotted line. Everywhere outside that line. When you say equal, when you have the equation of a circle, what that means is you are on the circumference. Any point, if you give me a xy coordinate and say, is it on the circumference, it has to equal that. In other words, when I plug in my x and y coordinates, it has to equal 36. That would put it on the circumference. If it's greater than 36, it's outside the circumference. If it's less than 36, it's in the circle. What you got?
Graph the solution set of this system. Y is greater than or equal to x squared minus 4, and x minus y is greater than or equal to 2.
First one is, now let's do the simple one. Let's do the second one. How do I graph that second equation?
So add y on both sides and subtract 2 on both sides.
Okay, so that gives us x minus 2 is greater than or equal to y. It means y is less than or equal to x minus 2. So that's the inequality. That be linear again?
Mm-hmm.
Goes through that point, has a slope of 1. And we have to be under that area. This, again, is a parabola that has been shifted down by 4. So that's that same parabola, only it now goes through here. And and I've got to be greater than the parabola, less than the line. Now, how do I know what this point is? In other words, when they say graph it, if they want an accurate graph, then I need this point and I need this point. If I want to graph this accurately, how do I get those 2 points? In other words, this graph I drew is just approximate. I don't really, if I was drawing it on grid paper, I would need that point right there, and I would need this point right here. In other words, I would need the coordinates of that and the coordinates of this. How do I get it?
The slope?
Set them equal to one another. In other words, you get intersections when this function is equal to this function. So if I set x squared minus 4 equal to x minus 2, I'm going to come up with this point and this point. Because when they cross, that's exactly what's going on, is one is equal to the other. Now I have to solve this. So I have a quadratic, so it's x squared minus x minus 2 equals 0. How's that factor?
X minus 2, x plus 1.
So this point right here must be 2, and this point right here must be minus 1. Now, to get the y coordinate, I just go into that. Or what was my second equation? Y is less than x minus 2.
Yeah.
So when x is 2, y is 0? Yeah. So I have not drawn my picture correctly. What am I missing? When x is 2, y is 0. And when x is minus 1, okay, this is all that needs to be modified a little bit. My line must do this. And that point is 2. 2 comma 0. And then over here, this point is minus 1 comma minus 3. Substituting in to the sequence. So there's my 2 points, 2 comma 0 and minus 1 minus 3. So actually it's a good idea I figured out what they were because I came up with a significantly different looking that area that you see everything above the parabola and below the line. But my original picture wasn't even close to right. I had the crossing point way up there. So it's, you need to figure out where these intersection points are in order to graph it properly. Alright, what else you got?
Graph the solution set y is less than or equal to 2 square root x minus 3. And then x is less than 8. So less than or equal to 8, and then y is greater than or equal to 0.
There's y equals greater than or equal to 0. X axis is that line. So everything there, that's bottom one. X is less than or equal to 8 is a vertical line. 8. So being less than means everywhere there. So far, we just got this area. Now we got rather this whole area. And then finally, the top equation. Well, for the moment, let's just draw these lines. I'll leave that one there and that one there. Now, what is this graph like?
It's like slant. It's like it goes up and it kind of evens out.
Yeah, and a typical one, in other words, y equals square root of x, up like that. Starts just goes up and flat like one. Well, how compared to that elementary function?
It's shifted to the right 3, and then it has a higher.
Yeah, a little bit of a vertical stretch to it.
Yeah.
So instead of looking like this, it maybe looks like this. Not really such that you can much tell the difference. And it starts here, but it closes dot. Because y can be equal to 3, excuse me, x can be equal to 3, but it has to be greater than 3. In other words, you're seeing the domain here. And now, y has to be less than that. Well, that's under that curve. Less than that means if I extend it everywhere under that curve, y can be. Well, if I want to be greater than 0, less than 8, and less than this curve, then this is the area with a solid line there, and a solid line here, and a solid line there. And now, this intersection, that's relatively easy to come up with. Just substitute x equal 8 in for here, and you have the y coordinate, so that would be 8 comma 2 root 5. And this point here is clearly 3 comma 0. So these are only 2 key points. Okay, what else?
Graph the system 2x plus y is less than or equal to 4, and y is greater than 2 over 3x minus 2.
Okay. Have you do it this time. Graph the first one.
Subtract 2x on both sides.
Okay. So I got y is less than or equal to minus 2x plus 4. So that's linear. Where do I start?
Graph the y-intercept, which is 4.
Okay, right there. What's the slope?
Down 2 over 1.
Okay, so if I go down 2 over 1, it's about like that. So which side of the line am I going to go?
Above the line?
No,
Wait, below the line.
when you have an inequality that's defined with y, then all you have to do is find a point on the y-axis that is less than this line. Based on this, y has to be less than or equal to this line. Well, if I find a point on the y-axis, there's a point on the y-axis. That means I found the side of the line that I need to find. You with me on how to do that?
Mm-hmm.
A lot of people seem to have trouble with that, and I think that's because they're trying to look in two dimensions when they look at this. They're not sure which side of the line to be on because they're confused by the x-coordinate also. But if it's y is less than this, then you merely need to look on the y-axis point below that line. If it was x is less than something, y, then I would look to the x-axis. I would find a point to the left of my line. But that's rare. You rarely have a linear equation defined by x, right? I mean, it's always y is equal to mx plus b. So you end up almost always having a y be on the other side. Okay, the second equation, where do I start there?
So plot the y-intercept, which is -2.
Okay, right there.
And then it goes up 2 over 3.
Okay, somewhere maybe like that. Which side of that line am I on?
You're on the top side.
Okay, because it's greater than, y is greater than that line. Okay, that gives my area as, not the area, as that, right there. And again, I don't know, point, that would be where, oh, let's figure out that point. Because if you actually have to do this on a test, you're going to want your graph to be accurate. So I set one y equal to the other y. Well, one y is minus 2x plus 4. The other y is 2x minus 2. So I need to solve that equation and give me that x-coordinate where those two lines intersect. Well, I multiply everything by 3 for starters. So I have 2x minus 6 equals minus 6x plus 12. Okay, that gives me 8x equals 18. So that is 9/4 is the coordinate of the x-coordinate right there. And then, of course, I could plug it into this equation to get the y-coordinate. Not equation, but inequality. A lot of times you treat inequalities like equations, like in order to find the intersection here, treat it like it's an equation. And since they're both in terms of y, and the y's are the same, then the left side has to be equal to the right side. Okay, what else?
Y minus x squared plus 2 is greater than 0.
I didn't hear most of that.
Y minus x squared plus 2 is greater than 0. And then x squared plus y squared is less than or equal to 4.
Is that it?
Yeah.
Okay, what kind of shape is this?
That is a parabola.
Okay, so let's solve it. Makes y greater than x squared minus 2. So we have a parabola and we have a circle. The circle has a radius of 2. The parabola has been shifted by 2 units down, so it's going to go through that point right there. Look something like this. Parabola, which way are we?
It's going to be above.
Okay, so it's above the parabola and inside the circle, right?
Mm-hmm.
So was this area here. Do we need more points on that? Yes, we do. We know this point right here. That is 0, comma, minus 2. But we don't know this point, and we don't know this point. So let's solve for those points. In other words, if you want to graph it accurately, if you were doing this in a test, would you be graphing it on grid paper, or would they just let you graph it and label the key points?
Grid paper.
Okay. So how do I figure out these 2 points?
So they're equal to each other?
Okay. So, what? Give me an equation.
So x squared plus y squared plus n, no, minus, wait.
In order to set them equal to one another, I have to solve this circle for y. Because then, that'll be y, and this is y, and then I can set them equal to one another. But until I do that, I can't really solve it. In other words, I can't set x squared plus y squared equal to x squared minus 2. That's not going to solve it. I have to solve the second one for y. What's the second one I solve for y?
Would be y is less than or equal to x plus 2.
First of all, it's the plus or minus x squared minus 4. In other words, all I'm going to do is move the x squared to the other side, negative x squared, excuse me. In fact, I'm sorry, let me get that differently. 4 minus x squared. And it's plus or minus because whenever you take the square root of an equation, you always start out with plus or minus as your answer. So now that I have both of them in terms of y, and incidentally, I really don't care about that direction at the moment. I know what area needs to be shaded. I just need to figure out these points. So to figure out the points, I'm going to treat everything as an equation. So now I've got plus or minus the square root of minus x squared. I'm going to set that equal to this y, which is x squared minus 2. Because at this point, they're equal. And at this point, they're equal. Also equal at this point down there. And in fact, if this parabola, if you were to shift it down one more notch, you would have 4 points of intersection. Well, let's see if we can solve for the x values based on what we have here. I'm going to solve this equation now.
Square both sides?
When I square both sides, it basically takes out my plus or minus, leaves whatever I have left inside. And then this squared is x what?
To the fourth.
Square that quantity.
X to the fourth minus,
one thing you want to be able to do, because you have to do it so often, is do a binomial squared plus and minus, and memorize it. So you don't have to FOIL it each time. If I memorize this, it's that. And this one looks exactly the same with a negative as the middle term. So by memorizing both of these, you can do things quickly like square that. Because in this expression here, a is x squared and b is 2. So it would be x to the fourth minus 2 times a times b, so that's going to be what's out there. That's squared
Add
Oh,
x.
I can take the 4's out.
Yeah.
So,
And I have now add x squared on both sides.
okay, so I'm going to end up with x to the 4th minus 3x squared equals 0. Now solve that.
X squared and then x squared minus 3.
What are our solution points for x?
0 and 3, negative 3?
Well,
0 and 3.
0 because of this one.
0 and
But then
3.
the other one is x squared equals 3, so x equals what?
3. Square root of 3 plus or minus square root of 3.
Plus or minus the square root of 3. Last one, 3 0. Right here, x is 1 square root of 3, and right here, x is minus square root of 3. And then I could come up with the equivalent one that is
Oh.
y equals x squared minus 2. Well, when x is 0, y equals minus 2. When x is plus square root of 3, y equals now when x is 1 root of 3. So there are your x and y values for all 3 intersection points. And that point for an accurate graph. Is that all we have tonight, or graphing inequalities?
Yeah.
Okay, well,
This is completely different. It's called matrices. Matrix. Those stuff.
matrices, okay.
So
What about matrices?
solve the following system. X plus y, x plus 5y minus 7b equals 2. And then negative 3x plus 4y equals 5. And then 2x minus 6y plus 3z equals 5.
First of all, do you know how to solve this manually?
We use calculators.
To do it with matrices?
Yeah.
Okay. Well, that's going to be hard for me to show you how to do. Did you use augmented matrices?
Excuse me?
Did you use augmented matrices?
I don't know what that is.
Well, let me see if I can describe how you would solve this using matrices. First of all, I've got the coefficient along the top row, coefficients of each variable, draw a vertical line and put the answers 2, 5, 5, like that. Is that what you did it?
Yeah.
On your calculator?
Yeah.
That's called, this is an augmented matrix. It's not a typical looking matrix. Most students don't have this solid line counts. But this is the coefficient matrix here. and this is the answer, the constant matrix over there. If I can make this matrix look like this, 1, 1, 1, and the zeros everywhere else, then whatever I have on the right, say 7, 5, 2, x is 7, y is 5, z is 2. So, and that's what you did in class, because you have the row echelon matrix, and then you have a reduced row echelon matrix. What I drew here is a reduced row echelon matrix. You don't necessarily need to take it all the way down to a reduced row. In other words, if I took it down to where I have ones across the diagonal and zeros under or to the left of each one, that will also allow me to solve it no matter what I have. I can have numbers up here like this. And the reason this allows me to solve it is because this allows me to solve for z, the last row. Once I solve for z, I can go and put it into this second row and solve for y. Once I solve for z and y, I can go into the first row and solve for x. So that's how you use matrices to do this. Now, when I say if I can manipulate this thing so that I get a diagonal of ones, what do I mean? Well, what we're looking at here is just equations. So I can switch rows anytime I want. In other words, I can make the first row be the second row. I can make the second row be the third row. Well, the first row already has that one right where I want it, so I'm going to leave that there. And then I've also got other rules here. I can add any two equations and replace the middle row with the sum of the first and the second, or the sum of the second and the third. Notice that if I, just as an example, I don't know if you need to know all of this or want to know all of this, or you just wanted to know how to put it into your calculator. But if you want to know, do you have a TI-84?
Yeah.
If you want to know how to put it into your calculator, the best thing I could do, but you can do it on your own, is to go to YouTube and say, reduced row echelon matrix on a TI-84. And it will show you a little 3-minute video that shows you exactly how to do it. And that's what I would have to do at this point, because I have a TI Inspire. I haven't used my TI-84 for about 3 years. So I don't even remember how to do it on a TI-84, but I would go to YouTube and look it up, and they would tell you exactly how to do it. But just as an example of what is going on, let's say I multiply the middle equation by -1 and add it to the first equation. Well, what does that give me? That gives me, let's see, it becomes 3 minus 4, 0, minus 5. And then if I add it to the first equation, I get 4, 1, minus 7, minus 3. You see what I did?
Mm-hmm.
Okay. What I'm attempting to do is, and I can still go ahead and put the third equation down there if I want, is I'm going to keep doing these manipulations until I have all ones and the diagonals and all zeros underneath my ones and to the left of my ones. And then whatever I have over here in this, to the right of the vertical bar will be my answer for that variable. Where this will be the x variable, this will be the y variable, and this will be the z variable. So I have to do whatever manipulations are necessary in order to make that 0, to make that 1, to make that 0, to make that 0, relatively straightforward to solve it for x and y. That is quite tricky to do. And like I said, if you're doing it on your calculator in class, then you probably don't ever have to do this manually. You put it in this format, and you tell your calculator to create the reduced row echelon matrix, and it spits back 1, 1, 1, zeros everywhere else. A vertical bar and your answer set. 3, 4, 5. X would be 3, Y would be 4, Z would be 5. I don't know that that's the answer for this problem, but in order to get the answer for this problem, you need to go into your calculator and do it. So, you want to figure that out on your own, or do you want me to bring up a YouTube video right now that shows us how to do it?
I can do it on my own.
Okay, because I don't have any problem doing that. It's easy enough to retrieve that YouTube video.
We went over how to do it on a calculator in class.
Okay, so you got it down.
Yeah.
Alright. Or if you don't, you know how to find out how to do it. It's just a question of memorizing it. But that's all the calculator does, is create a new matrix that has ones and zeros in it. What else you got?
If f of x is equal to 2x over 2 minus x, and g of x is equal to negative 5 over 2x, find f of g of x.
Okay. If f of x is equal to that, what is f of 3 equal to?
F of 3 is equal to 2 times 3 over 2 minus 3.
Okay. So whenever we have something inside the parentheses that's not x, is all we do is plug it in for x. So I want f of g of x. Well, g of x is this. So do f of minus 5 over 2x. Now, what is f of minus 5 over 2x going to be?
2 times negative 5 over 2x over 2 minus 5 over 2x. Negative 5 over 2x.
So make sure we don't lose a negative sign here. In other words, it's always good to use parentheses when you plug in a complicated expression, even when your original function is not complicated. In other words, we almost made a mistake there by having 2 minus 5 over 2x. Okay, now, how do we solve that expression? How do we simplify that expression?
Multiply negative 5 over 2x on the top and bottom.
Okay, these 2's cancel. Those 2's cancel. So my new numerator is minus 5 over x. What is my new denominator?
5 over x.
What is 2 plus 5 over 2x equal to? Add those two things together.
5 over x.
Need a common denominator.
Oh,
Need a
wait.
common denominator. What's the common denominator going to be?
2.
2x. In other words, it has to at least be this denominator.
And then
And then this will be 4x. The 2 turns into a 4x over 2x. plus 5. So when I complete this addition, I get this. Now I'm ready to flip and multiply. You know what I mean? Flipping and multiplying?
Yeah.
In other words, I have minus 5 over x times 2x over 4x plus 5. Now that x cancels with that x, and I'm left with minus 10 over 4x plus 5. There's my answer. That is f of g of x.
Why can't you simplify that further?
By doing what?
Like dividing by, wait, never mind.
It's okay. But one thing you cannot, not that you would anyway, but if I have a plus b over c, I can separate that into an a over c plus a b over c. But if I have a over b plus c, I cannot split that up. That is not equal to a over b plus a over c. So when I add that, I cannot split it up into two fractions. Might be able to divide top and bottom by a number, but in this case I can't. There's no greatest common factor that I can divide top and bottom by. So that's my final answer. Okay.
A shoebox's length is 3 inches longer than its width. Its height is equal to its width. Write an equation to represent the volume of the box in terms of width of the box.
Here's our box. What were the rules again?
The shoebox's length is 3 inches longer than its width. Its height is equal to its width. Write an equation to represent the volume of the box in terms of the width of the box.
Okay. What's the formula for the volume of a box equal to?
Length times width times height.
Okay, we're going to put everything in terms of W. WL is W plus 3 times W times W. In other words, height is W also. So my height is equal to W cubed plus 3W squared. Okay, write an equation for what? What's the rest of it?
Write an equation to represent the volume of the box in terms of the width of the box.
Okay, that's what we did. This was with length. What else?
What values of R would make the relation below a function? So R, 9, 5, 3, and 5, R.
What value of R would make this a function?
Yeah.
makes it not a function. No matter what R is. Except if R was 3. That's got to be the answer.
3?
In other words, I plot the only point that I know, 5 comma 3. And there's another point at 5 comma R, in other words, the same X value with a different Y value. That's not a function. If R is anything other than 3, it fails the vertical line test immediately. Right?
Mm-hmm.
There's nothing it can be except 3 so that it would be on the same point. In other words, if R is 3, then there's my point, and I really only have 2 points. One of them is 3 comma 9 right there. The other one is 5 comma 3. And the third one is 5 comma 3. That's the only thing I can figure out that they want. In order to make it a function, then R has to be that same value. And even that, I'm not quite sure if this violates the function rule. In other words, if I gave you these 3 data points, would that be a function? I think so.
Yeah.
Yeah. A function is, what is not a function is if you have multiple values of y for the same x value. You can have the same values of y for different x values. In other words, I could have 2 comma 3. That doesn't violate anything. It's just another point over here. But as long as I have 2 x values that are both 5, then the y values better be the same. If they're different, it's not a function.
Find all vertical and horizontal asymptotes. F of x equals 3x squared minus 3 and x squared minus x minus 2.
I'm sorry, what was it? Is it divided by something?
All over x squared minus x minus 2.
Okay. We need vertical asymptotes. How do we need all asymptotes? So, the vertical asymptotes are the easy ones to find. In order to find them, we need to factor this.
X minus 2x plus 1.
Now where's my vertical asymptotes?
2 and negative 1.
Where are my horizontal asymptotes?
3.
Good. And what else did you need to find?
Just those 2.
Okay. And you apparently know the rule on horizontal asymptotes. There's 3 different situations you can have. One is where the power of the highest x variable is the same as it is here. Then you use the ratio of the coefficients of just the highest variable. There is the situation where the power in the denominator is bigger than the highest power in the numerator. Where is the horizontal asymptote if that's the case? In other words, if you have something like x minus 2 all over x squared plus 7.
There wouldn't be a b slant.
No, there's 0.
0?
It's the x-axis always, if that's the situation. And the third situation is where the numerator is a higher value like that. If you find this, you have to do division, and if they're separated by exactly 1, you will end up with an oblique asymptote. That is a straight line oblique asymptotes?
Yes.
Okay. The way you get them is when the numerator is exactly 1 power greater than the denominator. So if I divide that out, I'm going to give you a linear vector like x minus 2 with some remainder. Well, that's the equation of your oblique asymptote right there. I'm not saying it's x minus 2. It's whatever you get when you do the long division. In other words, if I divide x squared plus 7 into x cubed minus 2, I'll get a linear result with some remainder. I don't care about the remainder. The linear result is the equation of the oblique asymptote. In other words, if it was x minus 2, then I would have an oblique asymptote that looked like this. Now, it's worth knowing that vertical asymptotes cannot be crossed. Horizontal asymptotes can be, and oblique asymptotes can be. In other words, with our problem here, if I wanted to graph that, there's no way my function can go across there. That's the whole point of a vertical asymptote, is x can never be these values. But for horizontal asymptotes, it would be possible to have a function do this. Cross asymptote and then come back and approach it as it goes to infinity. That is possible to do. Same thing it could do over here. It could cross the asymptote and come back and approach it. Remember, the definition of an asymptote is that's what the function approaches as you go to negative infinity on the x-axis or positive infinity on the x-axis. And the same thing if you happen to have an oblique asymptote. In other words, if I have a vertical there and a horizontal there, well, my curve could do something like this. It could cross that and then come back and approach it. So the only ones that can't be crossed are the verticals. All right, I've got an 8 o'clock, so I got to run, Nina.
All right.
That's been helpful to you.
Mm-hmm.
Okay, I'll talk to you.